topic is quantum number. What is quantum number? It is used to find the location of electron in an atom. To find the location of electron in an atom, there are 4 quantum numbers. 4 quantum numbers. Number 1 is principal quantum number. Principal quantum number. Number 2 is azimuthal. Azimuthal quantum number. And number 3 is magnetic quantum number. Number 4 is spin quantum number. Principal quantum number denoted by N, azimuthal quantum number denoted by L, and magnetic M, and spin by S. These 3 quantum numbers was given by Schrödinger. He was a scientist who gave these 3 quantum numbers, Schrödinger. But if we talk about the last one, 4 quantum spin number, it was found by spectroscopy. This is a technique, spectroscopy technique. It was found by this technique. And those 3 was given by Schrödinger, scientist. If we talk about number 1, principal quantum number. Principal quantum number. Basically, principal quantum number gives idea about the shells. Means principal quantum number gives information of the shells. If we talk about like N denote the number of shells. It is directly proportional to the atomic radius. How? Like these are the shells. In this, it's saying that when the number of shells will increase, automatically the atomic radius will increase. Like this is the number 1 shell, 2, 3, 4, K, L, M, and N. Number of shells will increase, so the atomic radius will also increase. This is means atomic radius. The atomic radius is directly proportional to the number of shells. This is the number of shells and notes the number of shells. In this we are finding azimuthal numbers of subshell. We are finding azimuthal numbers. For finding azimuthal numbers, the formula is n minus 1, where n represents the principal quantum number. Here if we find of the K, the subshell in K we are having, that is S, it's subshell. Now if we find the azimuthal number of S, here we are finding azimuthal numbers of subshells, not shells. So in this K we are having S subshell, so N, that is showing the principal number, which is number of shells. So number of shells, K is on number 1, so it will be 1 minus 1, N minus 1, 1 minus 1, that will be equal to 0. So the azimuthal number of S is 0. Now if we talk about L, L is having S and P subshell. Here it's in 2 number -1. Here we have find the S, that is 0. Now we are finding of the P, that will be 1P. The azimuthal number of P is subshell P is 1. Now if we find of the D, that is 3M, KLM. In M we are having 3 subshells, SPD. 3 minus 1, that will be 2. So the azimuthal number of D is 2. Now N, S, P, D, F. 4 subshells in N. We will find the S, P, D, now F. 4 minus 1, it will be 3F. The azimuthal number of F is 3. S, P, D, F. Here I am writing azimuthal numbers S0, P1, D2 and F3. These are azimuthal numbers of subshells. Now one thing I will tell here, that shells will be equal to subshells, which means if there is one shell, so there will be one subshell too. Like if I talk about K, in K we are having one subshell, that is S. So there will be K is on number 1. Here K, that will be one subshell, that is S. If I talk about L, there's 2, it's on 2 number, so it will be 2 subshells, that is S and P. So the shells will be equal to subshells always. If I talk about N, N is on number 4, KL, M, N. So there will be 4 subshells, S, P, D and F. So shells will be equal to subshells. Here we find the azimuthal numbers. I will also tell the shapes of subshells. S having a spherical shape, P having dumbbell shape, D having double dumbbell shape, double dumbbell shape, and F having complex shape. So these are shapes of subshells. Now number 3 quantum number, that is magnetic quantum number. Magnetic quantum number. It basically, magnetic quantum number gives orientation of the orbitals. Now what is orbitals? Here what are orbitals? Orbitals, it is place where of finding, where probability of finding electron is maximum. Which means in orbitals, what is orbitals? It is a place where probability of finding electron is maximum. Here I will tell you one thing. Here we are having shells. As we know, in shells we are having subshells, and in subshells we are having orbitals. In shells we are having subshells, and in subshells we are having orbitals. In orbitals, we will find two materials, that is number of orbitals, how many orbitals are in subshells, and orbital numbers. There is a difference between number of orbitals and orbital numbers. Now we will find here shell, subshell, number of orbital, and here orientation. Now K is a shell having subshell, that is S. Now how we'll find number of orbitals? Here is formula, that is 2L plus 1. This is a formula for finding orbitals, number of orbitals. 2L plus 1, where L is azimuthal quantum number, as I told before. So 2. What is the azimuthal number of S? That is 0. We find before it. So 2 zeros are 0 plus 1, that will be 1. So the number of orbital in S shell is 1. 1. Here I am writing 1 orbital. Now there will be 0 orientation. Orientation, which means axis. We are having 3 axes, X, Y and Z. Here we are having only 1 orbital. So the orientation will be same in, there is 1 orbital in S shell and there will be 0 orientation. Okay. If we find in L shell, there's 2 subshells, S and P. Here we find the of S, that is 1 orbital. Now of P, we have 2L plus 1. Now what is the azimuthal number? L of P, that is 1 plus 1. Here will be 2 and the 2. 2 plus 1, that will be 3 orbitals in P shell. 3 orbitals. So there will be 3 orientations. Now M, it's having 3 subshells, S, P, D. We have find the S, P, now D. 2L plus 1. 2 azimuthal number of D is 2 plus 1. 2 is a 4. 4 plus 1, that is 5. 5 orbitals in D. So there will be 5 orientations. Now N is having 4 subshells, S, P, D, F. We have find the S, P and D. Now F. 2L plus 1. Here 2 or azimuthal number of F is 3 plus 1. 3 to the 6. 6 plus 1 will be 7. So 7 orbitals in F shell, F subshell. 7 orbitals. So there will be 7 orientations. We have find the number of orbitals and orientations. Now as before we find the electrons in shells. Now electrons in subshells. How many electrons will be in one subshell? Okay. So if there is a K having S shell, for finding electrons in subshell, the formula is 2L plus 1. For finding subshell in electron, 2L plus 1 of the formula of finding electron in shells, 2 bracket 2L plus 1 of subshell. Here K, there's a 1 subshell, that is S. Here we'll find formula 2L plus 1, where L is the azimuthal number. Azimuthal number of S is 0. We also find before this. So 2 0 0 0 plus 1 will be 1. 2 ones are 2. So 2 electrons in S subshell. 2 electrons in S. Now L having 2 subshells. We have find the S. Now P. 2 12 plus 1, here 2, azimuthal number of P is 1, 2, 2 1 the 2, 2 plus 1, 3, so 3 to the 6 electrons in P, 6 electrons in P, this is in S. You can also see here in K shell, if we find before, in K shell we are having only 2 electrons in K shell, and you can see here in L shell we were having how many electrons? 8 electrons in shell, 8 electrons in L shell. Now see how 8 electrons. Now in S we are having 2 electrons, in P we are having 6 electrons. So 2 plus 3 is 6, is 8 electrons in subshell, in L shell. So here we are finding the subshells. Then when you will add these both, you will find the electrons in shells. If you will find F having 3 subshells, 2 12 plus 1, azimuthal number of D is 2, so 2 to the 4, 4 plus 1 5, 2 5, 5 to the 10 electrons in D. Now here you can see in M, S having 2 electrons, P having 6 electrons, and D having 10 electrons. Total electrons are 18 electrons. And you can also see before, as I told, if we have also find the electrons in M shell, we were having 18 electrons. So when we add these all, there will be 18 electrons in M shell. Okay, now N, S, P, D, F. Here we are having 2 12 plus 1. Azimuthal number of F is 3. So 3 to 6, 6 plus 1, 7. 7 to the 14. 14 electrons in F. So here you can see in S we are having 2 electrons, in P we are having 6 electrons, in D we are having 10 electrons, and in F we are having 14 electrons. These total are 32 electrons, and before we have also find in N we are having 32 electrons in N shell. So by finding the electrons in subshell, you can also find electrons in shell by adding these all. So these were the electrons in subshell. The formula is 2 12 plus 1. Now number 4 is, here that is difference between number of orbitals and orbital number. We have find the number of orbitals. Now we will find orbital numbers. Here orbital numbers. Finding orbital numbers, we are having formula that is plus L, 0 and minus L for finding orbital numbers. Here we are finding orbital numbers of shells. There is a S shell that having 1 orbital, as we find before, and having 0 orientation. Now what will be the orbital number? That will be the 0, because here plus L we are having no value in, because there is 0 orientation. Here only will be 0, you can see. Now in P we are having 3 orbitals. Here we were having 3 orientations. So here orbital number will be plus 1, 0 and minus 1. Plus 1, 0 and minus 1. These, here we are having 3 orientation. So 3 orbital numbers, plus 1, 0 and minus 1. And D. In D we were having 5 orbitals. And we were having 5 orientations too. So here how we will write 5 orientations? That will be plus 2, plus 1, 0, minus 1 and minus 2. You can see here these are 5. 1, 2, 3, 4, 5. Basically orbital numbers are orientations, but we are writing by its formula. here we were having 0 orientation, here 0 orbital number. 3 orientation, we have write it the 3 orientation. Here 5 orientation, these 5 orbital numbers, plus 2 plus 1, 0 minus 1 minus 2. Here you can see F having 7 orbitals, 7 orbitals, 7 orientations. So how will I write 7 orientation? That will be plus 3 plus 2 plus 1, 0 minus 1 minus 2 and minus 3. These are 7 orientations. So this is the way to write the orbitals, like orbital numbers by the orientations. So these were the orbital numbers, and this is the formula of orbital numbers. Now number 4 is spin quantum number. Spin quantum number. What is spin quantum number? Number 4 spin quantum number. I will tell that in every orbital, we are having 2 electrons. Like this is the orbital, these are 2 electrons, these are electrons. Remember this, in every orbital we were having 2 electrons. Like in in K shell we are having 1 subshell, in K we are having 1 subshell, that is S, and in S we are also having 1 orbital. We have also find before. So in 1 orbital we are having only 2 electrons. So you can also see in K shell we are having only 2 electrons. Now if you can see in L we were having 2 subshells and 3 orbitals. In each orbital we are having 2 electrons. So 2, 2 and 2, there will be 6 electrons. And you can also see in L shell we are having 6 electrons as we find before 2. So in every orbital we are having 2 electrons. Now you can see like this. This is the 2 electrons in 1 orbital. This is -1, negative half. This is positive half. This is negative half and this is positive half. This is negative half and 1/2. This is positive half. Now the negative half is a clockwise. Negative half is anti-clockwise. Anti-clockwise. How? Anti-clockwise is like this. This is anti-clockwise. Now the positive half is clockwise. Clockwise is like positive. This is clockwise. So here in electron this is positive half, that is shown like this, and negative half, that is shown like this. So that was a spin quantum number. This is a clockwise and this is anti-clockwise. This is -1/2, that is negative half, and this is positive 1/2, that is positive half. This is positive half denoted by this, and this is negative half. So these is 2 electrons. You can remember some formulas, that is for finding electron in shell, that is 2n square. Electron in subshell, for finding electron in subshell we are having 2, 12 plus 1, and for finding azimuthal number, that is n minus 1, and for finding number of orbitals, that is 2 L plus 1 for finding number of orbitals. For finding orbital numbers, that is L positive L, 0 negative L. That is for finding number of orbitals. You can remember these all formulas, so you can find electron in subshells, electron in shells, and azimuthal numbers, number of orbitals, and orbital numbers.